Hey everyone. So for today, we're going to be going into how we organize our data. Okay. This is something that we've been getting to because we've been trying to talk about how we do our experiments. We talked about everything up until we're doing it. Okay. And then yesterday we talked about the experimental method or the procedure. So we've gone over everything leading up to the experiment. Then we talked about making the actual procedure. So how we would complete the experiment. So for today, we're going to be going over how we would organize the data, and our aim is to describe how to collect data during an experiment in an organized way, which again, this lesson should be pretty self-explanatory, but we still should go through it because we want to look at how we organize it and a little bit into why we're organizing it that way and how we would evaluate it. Okay? So, as always, pause the slides if you need more time to copy down, but otherwise we're just going to get going. So data is information that we collect during an investigation. So whatever your dependent variable, your DV is, that's what you're measuring. That is your data, okay? And that data, those observations are typically going to be done based off of what we're seeing, hearing, feeling, right? Any kind of qualitative observation, or more likely than not, it's going to be a quantitative observation. So something that we're going to use a tool, a scientific tool or measurement in order to be able to do. So that's where we're talking about our thermometers, our rulers, our scales, okay? Any type of tool that we're using in order to record the data that's happening would be a quantitative type of observation that we're turning into data, okay? So we want to make sure that we're doing so in a logical way. And the best way we're going to do that is by creating a data table. Now, if you remember in class, we talked about how when we make a data table, we're going to be using our X and our Y. Now, I'm going to move the computer with me for a minute just so that I can show everyone this board right here to remind us what we talked about in class, if you were here in class, okay? Now, if you were here, you get to see this right here, okay? As you can see, you have the X and the Y. Your X is your independent variable and your Y is your dependent variable. That's just important to realize because whenever you're going to have your data, the independent variable always goes into the first column all the way to the left. And then the dependent variables, whatever information you're collecting and organizing, is going to be in the dependent variable in the Y columns, which are going to go to the right of it, okay? So that's like a cheat. Anytime that you see a data table and somebody says to you, hey, what's the independent variable? Well, that's going to be the first column. Whenever they say what's the dependent variable, that's going to be whatever's to the right of that first column. Sorry about getting up and walking around. I know it makes it a little jumpy and a little confusing, but it was important that you saw that. And I also know it was small in the bottom corner of the screen, but it should be a review. Okay. So we're going to take a look here. Data tables have a specific format, okay? You have to have titles for every column. There always has to be titles. And then they're going to have columns and rows. So the top of the column is going to have the name of whatever it is. And then below it is going to be where all your recordings are of whatever it is that you're measuring, and you need to make sure that you're putting the units. Everything in science should always have units, and it should always be to the 10th. So, right, we're changing. Our IV is time, okay? And we're measuring the height of the plant with fertilizer and the height of the plant without fertilizer. This is our DV, okay? So we're controlling the time when we're taking it, and then these are the types of data that we're recording, okay? So here, see how we put everything? Centimeters, okay? 0.0, 0.5, 0.0, we always want to be to the 10th place. We always want to have our units, okay? So the variable you change is listed in the first column, okay? If measuring change over time, time goes in this column, okay? So right here, we're measuring over time. Time goes in the first column. Data from your experimental groups are listed in the subsequent columns. So that's why we have our fertilizer and without our fertilizer, okay? We're going to be putting everything into our chart. That way it's easy to see all of it, okay? It's pretty self-explanatory. Right behind the video right here, it says data from experimental groups on these ones right here. Okay, I can't really say much more to this because you should be able to read a chart by now, but it's important for us to see it and just make sure that we're acknowledging that when we're taking data in science, it's always going to be to the 10th place and it's always going to have units. Okay. So, recording data in a table is important because it helps prevent mixing up measurements and observations for experimental groups. We need to have organized data. It's so important that everything be organized because otherwise our data is not going to be reliable or valid. We won't be able to reuse the experiment. It helps us prevent missing measurements or observations. You need to make at different points in the investigation. You'll know everything that you need to collect because it's going to be there available with the spaces to put into your chart. And then lastly, it helps you to analyze and interpret information better during an experiment, which is something that we're going to be talking about in terms of analyzing and making conclusions based off of our data, okay? Analyzing and interpreting the data, making conclusions based off of our analysis. So now we're just going to look at a couple of charts. We're going to talk about what's the independent variable, what's the dependent variable, and lastly, what are we getting from these charts? A little bit of analysis, okay? So for example, if I'm looking at water temperatures at various depths, right? I have my water depth in meters here. Okay, and I have my temperature in degrees Celsius here. So first off, what I would notice is that they didn't put these to the 10th place. If I were doing them, I would put the chart to the 10th place. But what I'm going to do when I'm evaluating this is I'm going to say to myself, okay, 50, 75, 100, is this increasing or is it decreasing? And I notice the numbers are going up, so it's increasing. Then I'm going to look at my temperature, 18, 15, 12, 5, 4. Okay, so my independent variable, what's in my first column? My water depth. I'm changing when I'm taking the temperature. My dependent variable, with my thermometer, I'm going to take the temperature. Here we go. So what have we learned? That as water depth increases, temperature decreases. Okay. I forgot to tell you guys to take a minute to pause the video and answer the questions, but that's our first example. So let's move on to the next one now. So right here, we have a data table about temperature and heart rate. I know I'm cutting off some of these, but that's okay because you could still see what's happening. Take a minute to pause the video and answer these questions. All right, good. So our independent variable, what is our independent variable in this one? It's the temperature. We're changing the temperature. We're making it get hotter, okay? And then our dependent variable is the way our heart rate changes, okay? So as temperature increases, what happens to our heart rate? It increases. So temperature, heart rate, and what have we learned? As temperature increases, heart rate increases. Last one. Right now, we're looking at the number of cases that somebody orders and the number of paper towels in each case, okay? So take a minute. What's the independent variable? What's the dependent variable? And what have we learned? Excellent job. So now that we've paused, we've answered our independent variable. We're changing the number of cases that we're ordering. And our dependent variable, what we're measuring is how many rolls of paper towel we get in each case. So in 1, we get 12, 3, we get 36. So as the number of cases is increasing, what's happening to the number of paper towel rolls? It's increasing, okay? So this is a pretty straightforward lesson. If you have any questions, feel free to contact me. I will be available to answer any questions. The homework is posted, and like I said, if you guys need anything, let me know. I'm hoping that we will be able to start streaming the lessons starting on Thursday. I will be contacting everybody in the stream on their classrooms, letting them know if we can begin live streaming. And lastly, I just wanted to let everyone know that my goal is that on Friday, you will be able to have a type of lab posted for everyone to do a lab so that they can use everything that we've been talking about in terms of the testable question, in terms of the hypothesis, the procedures, everything that we've been doing to try and put it together to do a lab. Have a great day, guys.